All right. So today we are going to talk about the applications of dimensions. Okay. So now we are familiar with the dimensions, how to find out dimensions of physical quantities. We'll see some applications of dimensions. So first one of them is to check if a given equation, given relation between the physical quantities is correct or not. Okay. So for an example, let's consider this equation. V square equals to U square plus 2AS. You know it's correct, right? This is which
Yes,
kinematic
sir.
equation? Okay, second kinematic equation. V equals to U, or third kinematic equation, depending upon how you by hearted it, right? So let's say this is third kinematic equation and we know it is correct. But if we didn't know that this equation is correct, how to find it out? How to check it? Using dimensions. So what to do is we'll find out dimensions on left hand side of the equation and dimensions on right hand side of the equation, and if dimensions of all physical quantities match, all the terms match, then the equation is correct, otherwise it is wrong. Okay, so let's find out the dimensions. So what are the dimensions of v square? What are the dimensions of v?
LT power minus 1.
L t to the power minus 1. So I want to find out dimensions of v square, or I can say it is dimension of v to the power 2. So L1 t raised to minus 1 squared. So it is L2 t raised to minus 2. And u is the initial velocity. So it is also velocity, so it will have same dimensions. So the dimensions are L2 t raised to minus 2. Okay, for u square also. Then here I have 2 times a multiplied by s. So in this one, 2 doesn't have any dimension. 2 is a number. Okay, it is dimensionless number, dimensionless coefficient. So it doesn't have dimensions. So we have to find out dimensions of a multiplied by s. Okay, so let's find out dimensions of a multiplied by s. So it is equal to dimensions of a multiplied by dimensions of s, and that's equal to what? L1 t raised to
LT power minus 2.
L t to the power minus 2 multiplied by L raised to
L.
1. Okay, S is displacement, right? So the dimensions are L2 t raised to minus 2, right? So dimensions of all terms, okay, so dimensions on LHS are equal to dimensions on RHS, right hand side, and dimensions of these two terms on right hand side, they are equal. So that means the equation is correct, right? Yes, no?
Yes, so.
Okay. So what it means is equation is dimensionally correct. Okay. It means equation is dimensionally correct. Why am I saying so? It's because we don't know whether about this multiplicative factor. It can be 2, it can be 10, it can be anything. Let's say instead of this equation, let's say I write some equation like this. V square equals to 5u square plus 25a multiplied by s. And now if you find out dimensions of this equation, what will happen?
It is also correct, dimensionally correct.
Yeah, so dimensions will match, right? Dimensions of these three terms will match because 5 doesn't have dimensions. Okay, it is dimensionless, just multiplicative factor, and this 25 also doesn't have any dimensions. But is this equation correct?
No, wrong.
It's wrong, right? I mean, it's wrong. Okay, so we know the third kinematic equation, it is v square equals to u square plus 2 times a into s. It is not equal to 5u square plus 25a multiplied by s. So we cannot find out about the multiplicative factor using dimensions. Okay, so what it means is if the dimensions of all terms in an equation are correct, okay, if they match, then the equation is dimensionally correct. We cannot say definitely about the multiplicative factor. Okay, But one thing is sure, let's say dimensions don't match, then what can you say? The equation is definitely wrong. Okay, so let's say in place of this thing, in place of u square plus 2 times a into s, I have 2 times a multiplied by s square. Okay, so let's do that. Let's add a page. Oh, what's happening? Where are all the controls? Oh, here they are. So, okay. So let's use this equation. V square equals to u square plus 2 times a multiplied by s square. So what will be dimensions? Now we know dimensions of v square are L to t raised to minus 2. Dimensions of u square are L to t raised to minus 2. But here, dimensions of a multiplied by s square will be equal to what? There is extra L. Okay,
L cube t power minus 2.
L cube t raised to minus 2, t to the power minus 2. And now they don't match. Okay, now the dimensions don't match. So this equation cannot be correct. It is not only dimensionally wrong, it is definitely wrong. It is wrong equation. Okay, you are sure about it. If an equation is dimensionally wrong, that means the equation is wrong. Okay, so it is not the check for the correctness of an equation. So what can we find out? Whether the equation is dimensionally correct. Okay, so if equation is not correct dimensionally, that means it is definitely wrong. Okay, so it is not check for the correctness, it is check for the wrongness. You got it?
Yes, sir.
Yes, Sharda? Sartha, right?
Yes, sir.
Okay, good. So this equation is definitely wrong. All right. So this is how to check whether given equation is dimensionally correct or not. Okay, this is how to check the correctness of an equation. So this is one of the use. Then let's move on to next use. The next use is to deduce the relation between physical quantities. As far as the NEET or JEE exam is concerned, this use is the most important use. To deduce the relation between different physical quantities. So for an example, let's consider this problem. The force acting on a particle performing uniform circular motion, UCM means uniform circular motion, depends on its mass, velocity and the radius of the circle. Okay, so force depends upon what? It depends on mass, it depends on the velocity and it depends on the radius. But we don't know to what power it depends on these quantities, right? So we have to find it out. Okay, so find the expression for the force. So it's given, what's given? That force acting on particle performing uniform circular motion, it's proportional to mass to the power something, let's say A, velocity to the power something, okay, B, and radius to the power something else, C. And we don't know what are the values of A, B, C. Do you know?
No, sir.
Do you know the formula for centripetal force?
MVR,
It is mv square upon r.
MV over 2.
Okay, so that we'll find out. Okay, so let's say we don't know this formula, so we can find it out using dimensions. So F is proportional to m to the power a, we don't know this power, b to the power b and r to the power c. And we want to find out what are these powers a, b, c. So we'll write F is equal to some constant k, okay, and this is just multiplicative number. Okay, this is just a coefficient, no dimensions. Okay, so k doesn't have any dimensions. K multiplied by m raised to a, v raised to b and r raised to c. And then now we can use dimensions. Okay, so we know dimensions on left hand side should be equal to dimensions on right hand side. So we can say that dimensions of force must be equal to, k doesn't have any dimension, so let's drop it. So dimensions of m raised to a, dimensions of v raised to b, multiplied by dimensions of c raised to, sorry, it's not c, it is r raised to c. Okay, so what are dimensions of f?
MLT power minus 2.
M L t raised to minus 2, m raised to 1, l raised to 1, t raised to minus 2. Dimensions of m are m raised to 1. Okay, so it is m raised to 1a. So I can write, or let's write like this only in this step. So it is l raised to 1 t raised to minus 1 for velocity. Okay, and to the power b. Then in multiplication we have r, which is radius. So radius means length. So L
L.
raised to, yeah, L raised to 1 to the power C. So now let's multiply this out. So it is 1A, 1B minus 1B and 1C. Okay. So M raised to A, then L raised to, what do we have for L? We have 1B, okay, that is B, and 1C. That means B plus C. Okay, we have L raised to B multiplied by L raised to C. That means it is L raised to B plus C. Yes or no?
Yes, sir.
Okay, so it is L raised to B plus C, and we have T raised to minus 1B. Okay, that is minus B. And now what do we need to do? Matching the dimensions on left hand side and right hand side of the equation. Okay, so we have m raised to 1 on left hand side, and on right hand side we have m raised to a. So that means this a must be equal to,
A is equal to 1.
a is equal to 1. Okay, then we have b plus c as power of l on right hand side, and on left hand side we have 1. That means b plus c must be equal to 1. Okay, and we have minus b as power of t on RHS, and on LHS we have minus 2. So minus b is equal to minus 2. That means b equals to 2. Okay, so let's write comparing dimensions on LHS and RHS. What do you get? You get a equals to 1, you get b plus c, b plus c equals to 1, and you get minus b, or minus b equals to minus 2, that means b equals to 2. And if you substitute that in here, so b plus c is 1, that means 2 plus c is equal to 1, or c equals to 1 minus 2. Okay, so 2 plus c equals to 1, that means c equals to 1 minus 2, that is minus 1. Alright, and now we got the powers, we can substitute them in that formula, in this formula. So what do you get? You get f is equal to k multiplied by m raised to what? M raised to a. So what is a? It's 1. M raised to 1. Then you have v raised to b. So v raised to, what is b? B is 2. And c raised to
Minus 1.
r raised to minus 1. Okay, r raised to c, which is minus 1. Right? So it is mv square divided by r. Right, if you take this r raised to minus 1 in denominator, it becomes r raised to 1, that is r only. So it's equal to, f is equal to k multiplied by m raised to 1 can be written as m v square divided by r. You got this formula, okay, which is exactly equal to the formula for the centripetal force, except for this multiplicative factor, which we cannot find out using the dimensions. Okay, that factor is equal to 1. Got it?
Yes, sir.
Yes, Sada?
Yes, yes, sir.
Okay. So this is how we use dimensions to relate different physical quantities. Okay. And there will be lots of problems based upon this. We'll solve some problems. Okay. And then there is another use to find the conversion factor between units of various quantities in different systems of units. Okay. So for an example, unit of force in SI system is what?
kg ms power minus 2.
Okay. So unit of force is Newton, right? We call it Newton.
Yes, sir.
Okay. So let's consider this example. Find the conversion factor between between Newton, which is unit of force. Okay, let's write Newton and dyne. So this is unit of force in SI system. This is unit of force in CGS system. Okay. So what will we do? So we know the dimensions of force. So what are dimensions of force? What are dimensions of force?
ml t power minus 2.
M1 L1 T raised to minus 2. Okay. So now let's suppose M suffix 1, L suffix 1 and T suffix 1 are the units of mass, length and time in this first system, the SI system. And M suffix 2, L suffix 2 and T suffix 2 are the units of mass, length and time in the second system. Okay. So let's say let L1, M1, T1, okay, and L2, M2, T2 are of units of length, mass, time and time in SI and CGS systems respectively. Okay, so we want to find out the conversion factor between Newton and dyne. So let's say N1, let's suppose N1 Newton equals to N2 dyne. Okay, so N1 Newton equals to N2 dyne. So I can say N1 multiplied by this Newton can be written as what? It is L1 M1 T1 raised to L raised to 1 M raised to 1 T raised to minus 2. Okay, and dyne can be written as similarly L raised to 1 M raised to 1 T raised to minus 2. And here the coefficients will be, sorry, not coefficients, the subscript will be what? 2 to 2. Okay, so L to the power 1, M to the power 1 and T to the power minus 2. All right, so then now I want to find out, let's say 1 Newton equals to how many dyne. So what I will do is I will substitute N1 equals to 1 and I want to find out N2. So let's say N1 is 1 and then I have L1 M1 T1 1 raised to L1 raised to 1 M1 raised to 1 T1 raised to minus 2, and I will take this thing on left hand side, so I will get N2. Okay, so it goes in denominator, so it is L2 m2 raised to 1 t2 raised to minus 2, and that is equal to n2. Okay, so what is unit of length in SI system? Meters.
Meter.
And in CGS system, centimeter. Okay, so I can write this as L1 upon L2 raised to 1 multiplied by M1 upon M2 raised to 1. Okay, I'm just dividing L by L, M by L, okay, M by M, and T by T, and whatever are the powers I will put them over here. Okay, so then it is T1 by T2 raised to minus 2. Alright, so let's substitute the units now. So this is 1, or L1 is what? It is unit of length. So what is that? Meter.
Meter.
Here it is centimeter. So meter
Centimeter.
upon centimeter raised to 1 multiplied by, this is kg
Kilogram
divided by
by gram.
raised to 1, and second by second
Second.
raised to minus 2. Okay, so this is 1. So 1 raised to anything is 1. Right. So now 1 meter is how many centimeters?
100 centimeter.
100 centimeter. And 1 kg is how many grams?
1000 grams.
1000 grams. So let's substitute that here. This is 100 centimeter. This is 1000 grams. Okay. And where is that? Okay. So it is 100 centimeters divided by centimeter raised to the power 1 multiplied by 1000 grams divided by gram raised to 1, and second got cancelled. Okay, so this is equal to, we can write n2. So now we can cancel out centimeter with centimeter, gram with gram, so we are left with 100 multiplied by 1000. So 100 is 10 raised to 2, 1000 is 10 raised to 3, so this is 10 raised to 2 multiplied by 10 raised to 3, that is 10 raised to 2 plus 3, 10 raised to 5. Okay, and therefore we got the conversion factor. So 1 Newton equals to 10 raised to 5 dyne. Okay, got this? Yes, no?
Yes, sir.
Everybody?
Yes, sir. Yes, sir.
Okay, so if there is a question like this in your exam, what will you do? Will you do all of this? Okay, will you write everything like this?
No, sir.
What will you do is, you will just write n2 equals to this thing. Okay, you will write like this directly. All right.
Yes, sir.
Okay, and instead of L1, M1, T1, etc., you will directly write down the units. Okay, so L1 is meter, you know that already. Okay, so just write meter raised to 1. Don't write L1 and then convert it into meters. Okay, it will take lot of time.
Okay, sir.
Okay, so there can be some questions like this also. So these are the 3 uses of dimensions. All right, so let's see some examples now. So let's see this example. The displacement of an oscillating particle is given by a sine of bx plus ct plus d. Then the dimensional formula for ABCD is. Okay, so what are the dimensions of A? Who can tell?
L.
L. Yes, it should be L, because see, here we have sine, okay, function, and sine function of any angle will give you what? It will give you a number which is dimensionless, okay, which is dimensionless, right? So this is dimensionless, and we have this formula for the displacement. That means the quantity on left hand side is displacement. So this a on the right hand side, which holds all the dimensions on right hand side, it has to be length only, okay? So dimensions of a are equal to as that of dimensions of length, okay? So dimensions of a equals to dimensions of y, and that's equal to L, I can say. So you got this, everybody?
Yes, sir.
Okay. Then this term here, we have sine of something. So what could be there inside that bracket? We take sine, cosine, or tan of which thing?
Fine.
Angle, no? We take sine of an angle, right? We take cosine of an angle,
Yes, sir.
okay? So this term inside the bracket, it must be an angle, okay? So what are dimensions of an angle? How do we define angle? What is angle? Theta equals to
Theta.
arc divided by radius,
Radius.
right? So arc, length of arc has dimensions of length, and radius also has dimensions of length. So length and length gets cancelled out. This gets cancelled out. So what are dimensions of theta? It is dimensionless, no dimensions.
Yes.
Okay. So it has got no dimensions. That means this b times x, c times d, c times t, and d have no dimensions. Okay. So I can say d is dimensionless already. Okay. So ct is dimensionless. C times t have no dimensions. That means dimensions of c are inverse to that of dimensions of t. Okay.
Yes, sir.
Dimensions of c must be inverse to that of dimensions of t. Okay. Therefore c times t is dimensionless. Got it?
Yes, sir.
So c times t is dimensionless. So you can write c times t is any dimensionless number k. Okay. Constant k. It's just a number, let's say. So dimensions of t are equal to dimensions of this k divided by dimensions of c. Okay, I'm taking c on the other side and taking dimensions of everything, right?
Yes, sir.
So dimensions of t and dimensions of c are opposite to that of each other. Okay, so actually I want dimensions of c only, so I will keep c on this side and t on the other side.
C is equal to 1 by T.
Yeah, so dimensions of c are 1 by t. That means t raised to minus 1. Okay, Sonali, you are trying to say something. Your voice is not clear.
Sir?
Are you saying something?
No, sir.
Okay, okay. So your mic was on and it was catching some noise. Okay. I thought you
Sorry,
were
sir.
about to say something, but since there is network issue, the voice is not clear. Anyways, This is clear?
Yes, sir.
Yes, Sonali?
Yes, sir.
Okay. So similarly, in same fashion, I can say b times x is also dimensionless, and therefore dimensions of b are inverse to that of dimensions of x. Okay, so dimensions
B is
of
equal to
b,
1 by L.
yes, b is equal to 1 by L. Dimensions of b are 1 by L, or I can say it is L raised to minus 1. And now we want dimensions of a, b, c, d. So what are they? It is, what are dimensions of a? They are L.
L.
Dimensions of b are L raised to
L inverse.
L inverse. So L times L raised to minus 1 times t raised to minus 1,
T inverse.
and d doesn't have any dimensions, so that means it is t inverse.
Dimensionless.
No, it is, this thing and this thing
T
gets
inverse.
cancelled out. We are still left with
T
a
inverse.
inverse. Okay,
Yes, sir.
okay. So it is t inverse. So which option? Option B, m0
B.
l0 t raised to minus 1. Okay, so this is the answer. Okay,
Yes, sir.
let's move on to next one. So next one is the dimensions of resistance are same as those of something. Okay, something from these options where h is Planck's constant and E is the charge, and we want to find out dimensions of resistance. Okay, so now what are dimensions of resistance? So we know the Ohm's law. Everybody knows Ohm's law, right?
Yes, sir.
V equals to Ri.
Is equal to IR.
Yeah, and therefore R equals to V upon I.
T by I.
Okay, and then what is the potential difference? Potential difference is work done per unit charge. Work done per unit charge to bring that charge from infinity to some point. Okay, that's potential difference between infinity and that point. So in an electric circuit, the potential difference between 2 points is work done per unit charge to move the charge between those 2 points. All right. So it is work done per unit charge. Okay. So E for charge. They are saying E is the charge. That's why I have taken E for the charge in place of Q. Okay. And I can be written as what?
Current amperes.
Yeah. So it is charge per unit time, right?
Yes, sir. Yes, sir.
It is charge per unit time. Okay. So it is charge per unit time. Now you can take that time in numerator. So you get work done or energy multiplied by time divided by E square. And now we want dimensions. Okay, so these are the dimensions of radius, sorry, not radius, resistance, and we want to match it with something from here. Okay, so which one would be the answer? See, we know about the Planck's constant. So energy or work is equal to what? H nu, or it is equal to H upon T. Okay, so if you take this T on left hand side, what do you get? Work times T. Okay, dimensions of work and energy are same. So energy of a photon is equal
Option
to
C.
h nu. Yes, it will be option C. Good. So in place of this WT, work multiplied by T, I can substitute what? I can substitute H. Okay. So W times T is equal to H. I can substitute. So what do I get? H upon E square are dimensions of I'm sorry, resistance. Okay, option C is the answer. Okay, so got it,
Yes, sir.
Sonali?
Yes, sir.
Okay, So this is simple, right? Once we know the formula, once we know most of the formulae, it is simple. Otherwise it's not. Then if we don't know the formula, we can't do anything. Yes, questions on dimensions are like that. Next question. C be the capacitance and V be the electric potential, then dimensional formula of CV square is. So actually dimensional formula for CV square is, okay, let's find it out. So what is capacitance? Do you know this? Capacitance is defined as charge per unit potential.
Yes, sir.
Okay, charge upon potential. Capacitance of a capacitor is charge stored on the capacitor divided by potential difference. Okay, so then CV square is equal to, I can say, Q upon V multiplied by V square. So this thing gets cancelled, one of the V gets cancelled out, right? And what is Q times
Yes,
V?
sir.
Okay, so you know what is potential difference? It is work done per unit charge, right? Potential difference between any 2 points is work done per unit charge. So you can take this charge on left hand side, so you get Q times V is equal to W. Okay, so this is equal to what? W, or work or energy. Okay, so actually energy stored on capacitor, there is direct formula for that. It is half of C into V square. Okay, but maybe if you didn't know that formula, Q times V is equal to what? Work. Okay, so the dimensions are equal to dimensions of work. So what are they? M1 L2 T raised to minus 2.
-2.
Which option? Option A.
A.
Okay, option A is the answer, right? So see, at least dimensions still work. We need to by heart. We need to memorize them. Okay, and the formulae.
Yes, sir.
Okay, so this is not difficult. Actually, if you learn electrostatics, then there is direct formula that energy stored on capacitor is half of C multiplied by V square. So dimensions of CV square are equal to that of dimensions of energy, that is dimensions of work. Okay, so if you know the formula, you have direct answer and you are saving at least 1 minute. Okay, any
Yes, sir.
questions, Sonali?
No, sir.
Okay, so let's see the next question. If force, work and velocity are taken as fundamental quantities, then the dimensional formula for time is. So now force, work and velocity are taken as fundamental quantities and we want dimensional formula for time. So now there is one way to solve this, which is the way we discussed. Okay, so let's solve it that way first. So I want time and my fundamental quantities are force, work and velocity. So it's given in the question that time depends on these three quantities. It depends on the force, it depends on work, it depends on velocity. But I don't know to what powers does it depend. So let's say it depends on work to the power A, sorry, let's take, yeah, in all the options work is first. So work to the power A, force to the power B and velocity to the power C. So then I can remove the this proportionality sign and put an equality sign. Okay, so till this it must be clear, right? So I have some formula for
Yes, sir.
time in terms of work, force and velocity, but I don't know what are the powers of work, force and velocity in that formula. Those powers I need to figure out using dimensions. Okay, so T is equal to some dimensionless constant multiplied by work raised to A, force raised to B, and velocity raised to C. So after that, I will take dimensions on LHS and RHS. Dimensions of T must be equal to K doesn't have dimensions. So they are equal to dimensions of work raised to A, dimensions of force raised to B, dimensions of velocity raised to C. And that is equal to L1, sorry,
ml square t
sorry,
power
sorry,
minus 2.
L2, it is L2. Okay, L2
Yes.
M1 T raised to minus 2 raised to A.
T power minus
Force
2.
is L1 M1
ml t power minus 2.
raised to B, and velocity is L1 T raised to minus 1
t
raised to
power
C.
minus 1.
Okay, then we have L raised to 2A. Okay, L raised to 1B and L raised to 1C. So it is L raised to 2A plus B plus C, right? It is L raised to 2A plus B plus C. Okay, then I have M raised to 1A, 1B, and yes, that's it. M raised to A plus B. So M raised to A plus B, and then T raised to minus 2A minus 2B minus 1C. T raised to minus 2A minus 2B minus C. Okay, and all of that. On left hand side I have T, that means T raised to 1. So do I have L on left hand side? I don't have. That means it is L raised to 0. Okay, I don't have M, that means it is M raised to 0. And I have T raised to 1, that means sum of these things is equal to 1. Okay, so let's write it. So we got three equations. So 2A plus B plus C is equal to 0. That's first one. A plus B is equal to 0. That's second one. And minus 2A minus 2B minus C is equal to 1. It's third one. Okay. So if we add this first equation and the third equation, what do we get? It's 2A and minus 2A gets cancelled, right? And plus C and minus C gets cancelled. So we are left with B minus 2B, that's minus B is equal to 1. Okay, let's call them 1, 2, 3. So adding 1 and 3, 1 plus 3 implies minus B equals to 1 or B is equal to
Minus 2
minus
is
1.
equal to 1. T is equal to minus 1.
B is equal to minus 1. Okay, then I can substitute that. And where should we substitute? Okay, so we can put A plus B equal
Equal
to
option 2.
which option?
A is equal to plus 1. I'm substituting. A is equal to plus 1. I'm substituting. B is
Yeah,
equal
yeah,
to minus 1 in option.
yeah, good. So in second I can substitute what? B equals to minus 1, so I get A is equal to 1. Okay, so I get A is equal to 1, and let's write it here, A equals to 1. And substituting that, what do we get? So it is 2 times A, so it is 2 times 1, 2, plus B, that is 2 minus 1 is 1, plus C is 0. So 1 plus C is 0, that means C is minus 1.
C is equal to plus 1. Minus 1.
1 plus C is 0, so C is minus 1, right?
C is equal to minus 1.
Okay, so which is the answer?
Option D. D.
Option D. Okay, it is A raised to, sorry, W raised to, where is A? A, okay, A is 1. Yeah, 1, minus 1,
Option D.
and minus 1. Okay,
Minus 1.
correct. So option D is the answer. Okay, so yes, this way we can solve it. So will you do this?
Yes, sir.
No, sir.
How much time will it take?
It take too much time, sir.
It will take too much time,
2
no?
minutes, sir.
Okay. So what is the faster way?
From option itself, we can
Yeah,
find the
yeah,
answer.
right. So from options, okay, just substitute the dimensions of these things F, W, and V in options. Okay. And you want time. Okay. Yeah, just substitute the dimensions in options themselves, and it will be faster than doing this, all this.
Yes, sir.
Yes, sir.
Okay. So yes, please remember this, because this type of questions will be there. Most number of times these type of questions are asked in NEET exam based upon dimensions. Okay. And these are simple quantities: force, work, and velocity. So in the recent trend is they are asking about, let's say, Planck's constant, then the universal gravitational constant, and velocity of light. See, they are taken as fundamental quantities, and find, let's say, dimensional formula for length or mass or something. Okay. So first of all, you need to find out dimensions of G, dimensions of H. Okay. Right. And sometimes they take epsilon
Yes,
also.
sir.
They take permittivity of free space. Okay. So it's better way is to, first thing is, if you can just in your brain, in your mind, if you can just combine those dimensions, okay, to find out the required quantity. First do that, okay, in split second. If you can't do that, then what should you do? Substitute the dimensions in options themselves. Okay, that will be much faster. Okay, because if you have universal gravitational constant, then Planck's constant, then epsilon, let's say, that means permittivity. So first of all, you will need to find out the dimensions, and then you will substitute. And let's say first you find out the dimensions, then you substitute. In this method, it will take 10 minutes or something, right? So you don't have that much time.
Yes, sir.
Okay. So I will prefer, basically, there is question like that. So forget about it for time being, solve other questions, then come back to it, and you can solve it easily by substituting the dimensions in options. Okay. Actually, it is actually short 4 marks you have, but you don't have that much time, because there is
Yes,
nothing
sir.
difficult in that. Those 4 marks are for sure. Okay. All right. Let's move on to the next question. The position of particle moving along y-axis is given as this thing, where y is measured in meter and t in second. Then dimensions of br. So sometimes there are questions like this also. This is from AMU. Do you know AMU? It is also
It
one
is
of
in
the
Benares.
no, BHU is Banaras. There was problem from BHU, Banaras Hindu University, and this is Aligarh Muslim University. Okay, so this is
No.
also
Okay.
a good university. Okay. Anyways, so we have this question: AT square minus BT cube. A equals to y equals to AT square minus BT cube. Okay, so now you tell me how to solve this. It is position. Okay, so all the terms should have dimensions equal to what? Length.
L.
Okay, yes, it is L. So dimensions of AT square are equal to dimensions of length, and that means dimensions of A are equal to what? Okay, we want dimensions of B only. I'm sorry.
Yes, sir.
I'm sorry. I thought we want A and B both. We want dimensions of B only. So we have BT cube. So dimensions of BT cube are equal to dimensions of length, and therefore we have B,
Option C.
right, option C. Okay, it is L. divided by t cube, okay, or L1 t raised to minus 3. So option C is the answer, right? Okay, next question. So in system of units, if force, acceleration and time are taken as fundamental units, then the dimensional formula for energy, is it repeated? Oh no, it was time, and this is, okay, the quantities are also changed. There was velocity. Force, acceleration and time are taken as fundamental units, then the dimensional formula for energy is, okay. So what to do? Shall we do all the process?
No, sir.
Okay, so we have got force, then we have got acceleration and time. Okay, so let's try to build a quantity having dimensions of energy using this. Okay, so can we do it fast? So what is energy in terms of force? It is force multiplied by length. Yes, no.
Yes, sir.
Okay, so dimensions of force we have, let's keep it like that only. We have got acceleration, which is L1 t raised to minus 2. Okay, so now what should we do with this t? We got F and L, this t is there. What should we do?
T square.
T square. Okay, so if we have FA, FA and t square, then the
D.
dimensions of that
Option
will
D.
be equal to dimensions of energy. Okay, yes, no?
Yes, sir.
Sonali got it? Yes or no? Okay, so see, sometimes these type of manipulations work. Okay, most of the times they will work. Okay, so all right, see how fast this is compared to using the method. Okay, using the process. All right, so first thing is try to build a dimensional formula for the required quantity using the given quantity. Second thing, if you can't do that fast, then second thing you can do is just substitute the dimensions of these quantities in all the options. Okay, let's say you put it here, let's say you put it here. So by the time you reach second option, you got the answer. Okay, all right, next one. So next one is the a force is given by F equals to AT plus BT square. What are dimensions of A and B? This is simple. So dimensions of A are equal to, so F is equal to AT, dimensions of F are equal to dimensions of AT, take T on the other side. So it is dimensions of force upon dimensions of T, that is L1 M1 T raised to minus 2, and this is T raised to 1 in denominator, so in numerator it becomes T raised to minus 1. So the dimensions of A are L1 M1 T raised to minus 3 and BT cube, BT square. So dimensions of B are force divided by T square, force upon T square. So it's equal to L1 M1 T raised to minus 2 divided by T raised to 2. And if you take it in numerator, it becomes T raised to minus 4. So L1 M1 T raised to minus 4. So what is the
Option
option?
D.
Option
D.
D. Okay, so option D is the answer. All right, simple question. Yes, let's move on to this question. The speed of light, the gravitational constant, and Planck's constant are taken as fundamental units in a system. The dimensions of time in this new system should be. Okay, so speed of light C, gravitational constant, and Planck's constant. All right, so can we build time using these? So do we know what are dimensions of G? So for that, we have to use this formula. Force between two masses is equal to,
G M1 M2 by M2.
oh, you remember? Good. So force is equal to G M1 M2 upon R square. So G is equal to Fr square divided by M1 M2. So that is L1 M1 T raised to minus 2 L to the power 2 from this R square and M raised to 2
M square.
M square. So it is L1, not
M
L1,
power minus 1.
it is L to the power 3, right?
L cube.
L cube
M
M
power
raised to
minus
minus 1 T raised to minus 2.
2.
Okay, so we got G, dimensions of G. And then we have Planck's constant. So what are dimensions of Planck's constant? So it is energy multiplied by time. Okay, so dimensions of
M L square T power minus 1.
L, M, no, it is M
M
L
L
square
square
T raised to
T
minus 1.
power minus 1.
Right, it is energy multiplied by time. And what else do we have? We have velocity
C
of light, c. It is L1
L T power minus 1.
T raised to minus 1. Okay, so can we build a quantity using this L3 we have, and we have to cancel out. Okay, so let's say I take G in numerator, these things in denominator, or their reverse. What will happen? This L will get cancelled out. Okay, but then what happens to the M? M doesn't get cancelled out, right? Because it is M raised to minus 1. Here we have M raised to plus 1. So it does not get cancelled out. What if I multiply them? Then M will get cancelled out. That we can do. So it will be, yes, if we multiply them, it becomes T raised to minus 2 and minus 1, T raised to minus 3. Okay, so I don't need M. I will cancel out M. So I will multiply G and H. What are their dimensions? Tell me. See, we have L raised to 3. Here L raised to 2. It is L raised to 5.
L power 5, T power minus 3.
Uh,
T power minus 3.
T power minus 3.
Minus
Okay,
3.
I wanted to cancel out M. That's why I multiplied them.
Yeah.
Okay, and then I have C. So if I raise C to the power 5, what do I get? C raised to 5. Okay, L raised to 5,
L
T
power
raised
5,
to
T power minus 5.
minus 5. Then I take the ratio of these two. I want
Divide
what? The dimensions of time, no? So I take ratio of these two. What do I get?
GH by L power 5. C power 5 is equal to
This thing
T
gets
power minus
cancelled.
2.
Yeah, T to the power, no, not minus 2, it will be plus 2.
Plus 2 plus 2
T
plus
square.
T square.
2
Okay,
square.
so T square, and then I will take square root of that. Okay, so my answer should be this thing. If I take square root of that, so this is T square, and I take square root of this now. Okay, so I get T. So answer is square root of GH
A.
upon C. Which one?
Option A.
Option A. Good. Okay, square root of C raised to 5 is C raised to 5 by 2. Okay, and because it is in denominator, it is C raised to minus 5 by 2. So option A is the answer. Very good. Okay, so see now how much time it could have taken had we solved it using the method. It takes a lot of time. Okay, so this is what we should do, and that too if we have time. Okay, getting this point? In
Yes,
last
sir.
few years, these kind of questions and with these quantities are being repeated. Okay, so pay attention what are we doing, and you will do the exact same thing. All right, let's move on to the Next problem. So dimensions of mu naught epsilon naught raised to minus half are, yes,
LT inverse.
LT inverse.
Inverse.
Okay, right. So this is formula for velocity of light.
C is equal to 1 by root of mu naught epsilon naught.
Yeah, c is equal to 1 by root of mu naught epsilon naught is the formula for velocity of light. So if you know this formula, then you know these dimensions. Okay, so exactly same thing is given over here, mu naught epsilon naught raised to minus half. Okay, so this is what? This is 1 upon mu naught epsilon naught raised to half square root. If you take it in numerator, it becomes minus half. Okay, so c is the velocity, and that's why dimensions are L t raised to minus 1. Okay, so this is simple if we know the formula, right? Okay,
Yes, sir.
so next question. So next question is, the energy, velocity and time are chosen as fundamental quantities. The dimensional formula for surface tension will be energy, velocity and time. So first of all, what is surface tension?
F by L.
It is F by L, or in terms of energy, okay, it is energy per unit area. Surface tension, I will call it, okay, I have time, so I will call it ST is equal to energy per unit area, or I can say it is energy upon L square, right? Area is L square. Yes,
Yes,
no?
sir.
So I have got energy, so I will keep it, okay. In this formula also I have got energy, so I will keep it, and I have to manage L square from velocity and time. So what should I do? Velocity is L1 t raised to minus 1, time is t raised to plus 1. So if I multiply them, I get, see, velocity multiplied by time is equal to what? L1 t raised to minus 1 multiplied by t raised to 1. So that is L raised to 1. And I want L raised to 2. That means what should I do? I should take its square. Okay, and the problem is
Yes, sir.
solved. So I have E divided by V square T square. See which is the option?
C.
Option C. Yes, option C is the answer. Okay, simple. Next one. Oh, again, the Planck's constant, speed of light, and Newton's gravitational constant are fundamental constants. Okay, which of the following combinations has dimensions of length? So earlier we wanted what? Time. Now we want length. All right. So let us copy the dimensions from a previous problem. Okay. So I will copy the dimensions from L3 m minus 1 t minus 2. So G has dimensions of L3 m minus 1 t raised to minus 2, right?
H is equal to ml square t power minus 1.
H is equal to
ml square
m1 L1 t
t
raised to
power
minus
minus
1.
1.
Okay. And what else we have? C. It is L1 t raised to minus 1. And now I want what? Length. Okay. So what should we do? We want length. So again, we have to cancel out mass. Yes. So again, if we multiply this with this, what do we get? G multiplied by H. So this thing, M gets cancelled out. We don't want it. So G times H is equal to, what is that? We have done that in last problem also. It is L1, okay, t raised to
L
t,
power 5 t power minus 3.
L to the power 5 t to the power minus 3. Okay, and then I want length. So what should I do? I want to cancel out this t raised to minus 3. So I will raise this to the power 3. Okay, c to the power 3. So it will be L raised to 3, t raised to minus 3, and I will divide that. So this thing gets cancelled, right? This thing gets cancelled, and I'm left with
L square.
L square. So I will take its square root. Okay, so square root of gh divided by c to the power 3 is L. Which
Option
option?
A.
Option A. Okay, hg divided by c raised to 3 by 2. All right, got the trick? Okay.
Yes, sir.
Okay, next question. If E, M, L and G denote the energy, mass and angular momentum and gravitational constant respectively, then the quantity, this quantity, okay, this is laborious task, has dimensions of, all right, it is E square. Okay, so E square L square divided by m to the power 5 g to the power 2, and we found the dimensions of G. They are L3 m minus 1 t raised to minus 2. Okay, so L3 m minus 1 t raised to minus 2 square we have. Okay, m to the power 5, and here L to the power 2, and here m1 L2 t raised to minus 2 square. Okay, not that difficult, right? So L2 multiplied by L2, no, not L2, this is L2 square. So L to the power 4 multiplied by 2, not multiplied by 2, multiplied by L raised to 2. So it is 4 plus 2, L raised to 6. So L raised to 6, we have M raised to how much? 2, M raised to 2 and T raised to minus 4. And in denominator we have M raised to 5 multiplied by, here it is L raised to 3, M raised to, okay, L raised to 3 square is L raised to 6, M raised to minus
Minus 2.
minus 2, T raised to minus 4.
Minus 4.
So something gets cancelled, L gets cancelled, T
L.
gets cancelled, and it is m raised to 2 upon m raised to 3. So 1 upon mass. None of these is the answer, right?
Yes, sir.
Okay, if my algebra is correct, none of these is the answer. Check it fast. Correct? Yes, no?
Sir, but L means angular momentum, no?
They told angular. Oh, I'm sorry. I did the mistake. They said angular momentum, right? So I thought it is length.
Yes, sir.
Okay, so angular momentum is mvr.
Yes, sir.
Okay,
M L square t power minus 1.
yeah, m. Okay, let's put it
L
here.
square.
M L square t raised to
L square t power minus 1.
minus 1. The Planck's constant and angular momentum have same dimensions. Oh, I did the mistake. Sorry. So now what do we have? Okay, so we have to read the questions properly. Yes, so it is m raised to 2, m raised to 2, that is m raised to 4, right? M raised to 2 from here, m raised to 2 from here, yeah, m raised to 4. Then we have L raised to 2 square, it is L raised to 4, and from here it is L raised to 4. So L raised to 8 we have multiplied by T raised to minus 2 square minus 4. and t raised to minus 6. T raised to minus 6. Okay. So still I think it is t raised to minus 6 divided by minus 4. It is minus 2. Okay. M raised to 5 minus 2 is 3. So 4 by 3 is 1. So we have m multiplied by L raised to 8 divided by 6 is L raised to 2. Okay, so what is this? M1 L2 T raised
None
to
of
minus 2.
this.
Again, none of this. This is energy, right?
Yes, sir.
Okay, none of this. So now calculations are correct, no?
Yes, sir.
I think so. Okay, so none of this. All right. So we took L as length. Still, it was none of this, fortunately, and L as angular momentum. Still, the answer is none of this. Okay. All right. So yes. So this is how we will solve questions based upon dimensions. Okay, and mostly questions will be like this only, either to find out the dimensions of some terms given in an equation or to relate the fundamental quantities. So sorry, to relate the physical quantities. Okay, so checking an equation, there were not many questions based upon that. Actually, there were no questions on that. Okay, so got it.